No matter for the people from the computer science major or people with non-CS background, but interested or use knowledge related with the CS, you may ask yourself how to learn CS efficiently sometimes. Here are some useful ideas for you. Courses of computer science major in college are usually divided into two main tracks, namely the algorithm and system. The courses such as math, numerical analysis, data structure, machine learning, or deep learning belong to the algorithm track. For the system track, it includes courses such as operating system, computer architecture, and networking, and so on. Courses in this track mainly focus on how to wisely manage all kinds of resources of computer, such as CPU cores, networking, and storage devices in an efficient way. I believe these two tracks are common for most of people. Is it enough? Is it enough even if you're a specialist in computer algorithm or system? If you're a CS student and got A for all of these courses, you may get a decent offer from the high-tech company, but this knowledge could not guarantee you to make a big success in your career. If you're a non-CS student, you may find there are all kinds of fancy technologies, 5G, blockchain, cloud computing, big data, but when you try to learn these courses, this knowledge may not necessary to help you in a large degree. How to find the most suitable one? And what is the gap here? Another dimension we may easily neglect is the view of the application. That is a crucial part and is always ignored by people. In particular, the thought in this application view aims to use the knowledge and the tools or softwares of the computer science to facilitate applications from different kinds of industries or use case scenarios. The key point here is to realize that the software or computer science is just a kind of tool in some degrees. The more important thing is the application. The tool should serve the application. The development of softwares should be driven by the application. That is why that only programming is not enough to create profits. Only programming for the right thing can create profits. Even if you are doing a research about the computer science, if you could not explain how your project may serve the application and make it faster, more accurate, or save more time, your project might go to a wrong direction. On the other hand, if you do not have a deep understanding about your applications and use case scenarios, you may not find which part can be accelerated or automated by the technologies from the computer science. The new technology is not free. Only if putting it in the right place can create values. The value will be created if you use the knowledge from the computer science to solve a proper problem in a specific area. Unfortunately, the school does not provide these kinds of courses, and we need to explore it step by step after we graduate from the college. This is obvious in the design of the domain-specific software. Sometimes you may find, even for people from the CS background, they may not quite understand the works from other people, even though they both have a good understanding about the algorithm and system. This is mainly because the gap of the application level. In a real project, the first requirement is the breadth requirement, since the workable project requires the knowledge from application, algorithm, and even the system view. The ideal case is that you know necessary knowledge in these domains, but it is hard for everyone to know everything. Even if you are a specialist in computer science, you still need to work with domain experts to figure out what they really want in application view. For example, if you develop clinic softwares, you may need to understand how the doctor wants the software to work. If you develop softwares for the financial service, You may need to figure out the basic process about the financial transaction. In the college, only some high-level courses may fall into the category of the application view, such as how to use artificial intelligence in computer vision or natural language processing, how to use parallel computing in scientific simulation, and how to use artificial intelligence and computing graphics in robotics. These kind of courses break the boundaries of the algorithm and the system, and consider the problem from the perspective of the application view. You may find both the knowledge of the algorithm and system are used, and this knowledge are organized from the application's perspective and driven by the application. That is how breadth requirement works. Let's say the depth requirement. For people with non-CS background, you may even not need to understand the details about the algorithm and system. The most important thing is to know how to use particular software related with your domain. The crucial part is the deep understanding for the domain knowledge and how it can be improved based on the new technologies. It is also crucial to get familiar with particular software in your domain. You just need to know how it works instead of why it works. Besides, you may also need to try to learn how to cooperate with people from the CS background and have the general picture about the limitation of the CS technologies. For people with a CS background, depth requirement means that you should choose a specific direction as your main direction, namely the system or algorithm. By this way, you could have enough understanding for the specific direction. For example, if you focus on machine learning algorithm for the most of your time, maybe use 80% of your time to learn the specific algorithm and use another 20% of your time to learn how to deploy them on different systems, how to store the data, and how the infrastructure handle the underlying communications in distributed system. That may provide you different views of understanding the algorithm. On the other hand, if you focus on system part, such as compiler or storage system, maybe it is also good for you to take 20% of your time to learn the latest algorithm in machine learning or artificial intelligence and to see what algorithm can be used to better solve the system problems. You may not need to understand every details about this algorithm, but it is useful to know the general ideas and what they can do. You could say that the popular project in real world always cover basically all these categories, and it is interesting to consider what kind of knowledge are used in different views. For example, the TensorFlow framework. If you consider it from the application's view, computer vision and natural language processing are typical using scenarios. You can use the framework to train classifiers and detect objects in figures or videos. For the system view, it can run on distributed system or smartphone. We could consider how these services interact with each other. What RPC calls are used here. For the mathematical view, it covers all kinds of fancy machine learning technologies. Maybe that is one reason it is so successful. You could find the state-of-the-art techniques from different views in this project. What is the conclusion in this video? Computer science or programming is just like a second language. If you are only a specialist in it, you may become a good teacher for programming. But how to let it to create values is more important. You may need to consider how to convey your ideas and tell your stories by this tool. That is how it works in real world. It is important to find your location or cooperate with other people and to do it in a wise way. Thanks for watching and see you next time. What is the conclusion in this video? Computer science or programming is just like a second language. If you are only a specialist in it, you may become a good teacher for programming. But how to let it to create values is more important. You may need to consider how to convey your ideas and tell your stories by this tool. That is how it works in real world. It is important to find your location or cooperate with other people and to do it in a wise way. Thanks for watching and see you next time.